Hi, we are from Group 4. We will talk about Cauchy integral formula. The members are Febriani Nursyafitri, Wela Ardha Permatasari, and Suari Nugraheni. First, Cauchy integral formula. The theorem is let f be analytic everywhere inside and on a simple closed contour C taken in the positive sense. If Z0 is any interior to C, then function of Z0 is equal to 1 over 2 pi integral of Fc over Z minus Z0 dz. It is equals to integral of Fc over Z minus Z0 dz equal 2 pi Fc0. The proof is integral of Fz over Z minus Z0 dz is equal to integral of Fz minus Fz0 plus Fc0 because minus Fz0 plus Fc0 is equal to 0 over Z minus Z0 dz equals to integral of Fc minus Fc0 over Z minus Z0 dz plus Fz0 integrals of dz over Z minus Z0, and let integral dz over Z minus Z0 is equal to integral of k dz over Z minus Z0 with k Z minus Z0 is equal to 1. R is equal to 1. Then integral of k dz over Z minus Z0 is 2 pi. This is the first equation. Then Fc0 integrals of k dz over Z minus Z0 is equal to 2 pi Fc0. Because f analytic at C union integral C, so the derivative of Fz exists for Z element C union integral C. Because Z0 is element integral C, then derivative of Fc0 is exists. This f is continuous in C0. This method means for every epsilon more than 0, there is delta more than 0 such that Fz minus Fz0 less than epsilon if Z minus Z0 less than delta. And this is the area of Z0. Let integral of L Fc over Z minus Z0 dz equal to 0 plus Fz0 times 2 pi is equal to 2 pi times Fc0. Then integral of C for function Z minus function Z0 over Z minus Z0 dz is equal to integral L Fz minus Fz0 over Z minus Z0 dz, with L is equal to Z, where Z minus Z0 is equal to lambda, less than equal to delta over 2. Then 0 is less than equal to integral of L Fz minus Fz0 over Z minus Z0 dz, less than or equal epsilon over lambda times absolute of L is equal to epsilon over lambda times 2 pi lambda, where absolute of L is equal to 2 pi lambda is equal to 2 pi epsilon. Thus, integral of fz minus fz0 over z minus z0 dz is equal to integral of L fz minus fz0 over z minus z0 dz is equal to 0. This is the second equation. Then, from equation 1 and equation 2, we get integral of L of fz over z minus z0 dz is equal to 0 plus function of z0 times 2pi is equal to 2pi times fz0. For the example, determine integral of z dz over 9 minus z squared times z plus I, where absolute z is equal to 2, where c is positive orientation. The solution is integral of z dz over 9 minus z squared times z plus I is equal to integral z of z dz over 3 minus z times 3 plus z times z plus I. For the singular points, we get z1 is equal to 3, z2 is equal to minus 3, and z3 is equal to minus I. And this is the area of the singular points. And we choose z0 is equal to minus 1 so that fz is analytic in C union integral C. Then integral C of z over 9 minus z squared over z minus negative I dz is equal to 2pi times f z0. Then is equal to 2pi times f of minus I is equal to 2pi times minus I over 9 minus negative I squared, and the result is we get p over 5. Thus, the result of integral z over 9 minus z squared over z minus negative I dz is equal to p over 5.
Now, I will explain you about derivative of analytic function. An extension of the Cauchy integral formula. The Cauchy integral formula in the theorem in section before can be extended so as to provide an integral representation for derivative of f at z0. To obtain the extension, we consider a function f that is analytic everywhere inside and on a simple closed contour C, taken in the positive sense. We then write the Cauchy integral formula as fz equal to 1 over 2 e integral fs over s minus z ds, where z is interior to C and where s is denoted point on C. Differentiating formally with respect to z under the integral seen here, without rigorous justification, we can find that f prime z, or the first derivative of fz equal to 1 over 2 pi integral of fs over s minus z squared ds. To verify that the first derivative of fz is exists and the expression 2 is in fact valid, we let d denote the smallest distance from z to point s on C and use expression 1 to write. You can see here to write f z plus delta z minus fz over delta z equal to 1 over 2 p a integral of 1 over s minus z minus delta z minus 1 over s minus z, fs over delta z ds equal to 1 over 2 pi integral of fs over s minus z minus delta z times s minus z ds, where 0 less than the absolute value of delta z and less than d. Eventually, then we got the equation 3. You can see the equation 3 above, and below the equation 3 we can see the region of a d and s minus z absolute value, and then we can see the absolute value of 3 delta z. All of that still in the area of C. Next, we let M denote the maximum value of absolute value of Fs on the C and observe that since absolute value of S minus Z more than or equal D and absolute value of delta Z less than D. So we have the absolute value of S minus Z delta equal to absolute value of S minus Z minus delta Z more than or equal absolute value S minus Z minus absolute value of delta Z more than or equal D minus absolute value of delta Z more than 0. Thus we have the new equation. You can see the figure where L is the length of C. Upon letting delta Z tend to 0, we find from this inequality that the right-hand side of equation 3 also tends to 0. We have the consequently, like the equation below, you can see the limit of delta Z tend to 0, fz plus delta Z minus fz over delta Z minus 1 over 2 pi integral of fs over s minus z squared ds is equal 0, and the desired expression for the first derivative of s is established. The same technique can be used to suggest and verify the expression. Then we can get the equation 4 or the second derivative of fz. Mathematical induction can, moreover, be used to obtain the formula. We have the 5 equation. That is, if we want to integrate our derivative more than 2, we can use the equation 5. The verification is considerably more involved than for just n equal 1 and n equal 2, and we refer the interested reader to other things for it. Note that the agreement that f0z equal to fz, and then f equal 0 equal to 1. Expression 5 is also valid when n equals 0, in which case it becomes the Cauchy integral formula, the first equation. Then, when we written in the form, we have the 6th equation. If the expression 1 and 5 can be usable in evaluating certain integral, where f is analytic insight on a simple closed controversy taken in positive sense, and z0 is any point interior to C. Example 1. If C is the positively oriented unique circle, absolute value of z equal 1 and f z equal to exponential 2z, then we have the integral of exponential 2z over z power 4 dz equal to integration of fz over z minus 0 power 3 plus 1 dz. Then we have 2 pi over 3. Then the third derivative of 0 is 8 pi over 3. The example 2. Let z0 be any point interior to a positively oriented simple closed contour z. When Lz equal 1, expression 6 show that the integral of dz over z minus z0 equal to pi, and then you can see the equation below that.
So the next is Marina Theorem. So what is Marina Theorem said? Let function f be continuous on domain D. If integral f of c dz along c is equal to 0 for every closed contour c in D, then f function is analytic throughout D. In particular, when D is simply connected, we have for the class continuous functions defined on D the converse of the Cauchy-Korsakoff theorem to such domains. So the Marina theorem, usually called as the converse of Cauchy-Korsakoff's theorem. So we will prove the Marina theorem now. If we observe that when its hypothesis is satisfied, where function f be continuous on a domain D, if integral f of c dz along c is equal to 0 for every closed contour c in D is satisfied. The Cauchy-Korsakoff theorem ensures that function f has an antiderivative in D. That is, there exists an analytic function capital F such that f capital prime of c is equal to f of c at each point in D. Since function f is the derivative of capital F, then f is analytic in D. So, the Marina theorem is proved. Now, we will use the Marina theorem to solve a problem. We have this example. Evaluate integral sinus c over z minus 5 power 4 dz along c with c is absolute c equal to 4 and c positively oriented. Firstly, we draw the diagram. Since the center of circle C is 0, we have here from absolute C, z minus z0 is equal to 0, so we have the z0 is equal to 0. So the center of the circle is at point 0, and then the radius of circle C is 4. Now we have the solution. The first step, we let the f of c is equal to sinus c. Then f is analytic on c and integral c. And we have integral sinus c over z minus 5 power 4 dz along c is equal to integral f of c over z minus phi I power 4 dz along c is equal to 2 phi I over 3 factorial multiplied by triple prime of f of phi I. We have this because of the derivative of analytical function before. Now, since f of c is equal to sinus c, then we obtain f prime of c is equal to cosine z, and f double prime of z is equal to negative sinus z, and f triple prime of c is equal to negative cosine z. And now we evaluate f triple prime phi I. We already have that it's defined negative cos phi I, and we also have the definition of cosine in complex analysis. So we have negative a half exponential pi plus exponential negative phi. We simplified it by using Euler formula. So we have negative a half multiplied by cosine phi plus I cosine phi plus cosine phi minus I sinus phi. We have then negative a half multiplied by negative 1 plus 0 plus negative 1 negative 0 is equal to negative a half multiplied by negative 2 equal to 1. So the integral sinus c over c minus 5 power 4 dz along c is equal to integral c f of c over z minus 5 power 4 dz along c. From the evaluation before, the calculation before, we have 2 phi I over 3 factorial, which is 6, and multiplied by f triple prime of phi I is equal to 1. So we have 1/3 phi I. So we come to our conclusion. In Cauchy integral formula, derivative of analytic function and Marina Theorem. Cauchy integral formula, we have integral f of z over z minus z0 dz along c equal to 2 phi I f of z0. And the derivative of analytic function, we have f prime z0 over a half phi I integral f of z over z minus z0 power 2 dz along c, and so on. And then we have f prime n over z0 is equal to n factorial over 2 phi I integral f of z over z minus z0 power z power n plus 1 dz along c. And we have the Marina Theorem. If f be continuous on a domain D, if integral fc dz along c is equal to 0 for every closed counter c in D, then f is analytic throughout D. So this is the end. Thank you for watching.